So let's continue with the next speaker. So we're happy to have with us Alvaro Zanón from Hopewind. He's the Utility Technical Support Director based in Europe, and he will talk about the power of digitalization in utility PV inverters and storage. Alvaro, welcome.
Good to see you again, Michael. How are you? Let me share my screen. How are we on timing, by the way?
I think
Just to be aware of that.
Yeah, it's all
Good.
good. Yeah.
Okay. Wait a second. We don't want to share the whole screen. Let me know when you see it, okay?
Yep.
Okay, so yeah, as Michael said, I am Alvaro Zanón. I am the technical director for utility projects in Hopewind. So today's presentation is going to be focused on the role of digitalization or the power of digitalization, specifically to utility and storage, big storage projects. So we have a very short company introduction, just a few slides, just for those of you guys that you still don't know us, and then we get into the details. So Hopewind, as you can tell by the name of our company, wind. I mean, we come from the wind industry. Already in 2007, we started developing converters for the wind industry, and very soon we became the number one supplier, first in China and a few years later worldwide. So it means that we don't do the wind turbines, we do the converters for the wind turbines. We are experts in power conversion systems. And later on, we started developing our PV business with especially the PV inverters. And also, as you can see there, we can also provide today solutions for storage application, hydrogen converters, and variable frequency drives. So up to today, we have more than 150 gigawatts installed worldwide, and we are listed in the Shanghai Stock Exchange market. We are a global company with headquarters in Shenzhen, in the south of China, with 5 R&D and manufacturing centers. Actually, recently we opened our new factory in Heiyuan with a capacity of a size of 175,000 square meters. And we have a production capacity for the utility inverter exclusively of 20 gigawatts annually, which can be rapidly expanded in case we need it. And as a global company, we have presence in many countries worldwide, 30 countries, and with actual presence, physical presence in 8 countries, as you can see there: Netherlands, Brazil, South Korea, Turkey, Vietnam, Pakistan, India, and Indonesia. That's it about the company introduction. As I said, very brief. So we get into the product overview and later to the digitalization part, which I think is the key topic of this presentation. About our product portfolio, I'm not going to get into all the details, but just for you guys to know, we have solutions for hybrid residential solutions between 5 and 12 kilowatts. Together could be coupled with EV chargers and batteries. In the residential PV solution, we have string inverters for both single-phase and three-phase applications, up to 33 kilowatts. In C&I applications, our range of products of power goes from 25 to 110 kilowatts. Actually, we can reach more than 110. It's already in 120. And the focus of today's presentation is the last 2 columns that you can see in the presentation: utility PV products and storage applications. Specifically, the inverter that you see in the middle, the 320 to 385 kilowatts. Together with that inverter, we can provide transformer stations that they come in 3 different sizes: 3,000, 6,000, and 9,000 kVAs. And for storage applications, we also have our string ESS PCS that can go up to 250 kilowatts. And together with that, we can provide the PCS station in which we integrate as many PCS as the project needs. But we also incorporate the transformer, the medium voltage station, the medium voltage switchgear, auxiliary systems, and so on. So right now, we're just looking at the utility PV and storage solution. So first, we're gonna take a look at this string inverter. As I said, it goes from 320 to 385 kilowatts. Actually, 4 different sizes: 320, 330, 350, and 385. And the inverter has been designed with 4 principles in mind: flexible design, grid friendliness, safety and reliability, and LCOE. Flexible design, because this inverter can accommodate any type of module. Talking about the standard modules, which have a current of 14, 15 amps, and also large current modules or bifacial modules that they're using 210 millimeter wafers. Other things that are specific about our inverter is that it can work as a standalone STATCOM, so meaning that it doesn't need any DC voltage to provide reactive power, and flexible DC and AC cable options. So on the DC side, we can reach 10 square millimeters, and on the AC side, we have 2 options. One of them is for 400 square millimeter cables per phase. And the other option, which will be available in 2025, will be 2 cables per phase of 240 square millimeters. Safety and reliability, of course, this is the center of our DNA, with a very strong IP protection level, corrosion level, with potentially induced degradation options for the called PID recovery and anti-PID. I will cover that in the digitalization part. We also included a commissioning safe mode, which you can see in the picture at the bottom left side. There's a small black switch that is intended to be used during the installation of the PV strings. When there is a reverse polarity connection, the inverter will detect it, but it will allow installers to troubleshoot it directly on the spot without having to wait until the nighttime, because you cannot do it during the daytime because the strings are energized. And also this feature will detect if there is any faults on the DC cables, inputs on the terminals, and so on. AFCI, arc fault circuit interrupter. This is common for residential and C&I applications, but now since last year, there's a new IEC standard that covers that topic for utility projects for series arc faults. I will cover that later also. Grid friendliness, of course. The inverter has to be compatible with any grid codes worldwide. It has to be easy to maintain, to troubleshoot, to load firmware updates, commissioning, and so on. So this is the DNA of every, I would say, string inverter. And the best LCOE, why do we say that? Because we have the largest inverter in the market, 385 kilowatts, but up to 40 degrees. So with that, you need to install less inverter, less trenches, maybe a higher or larger cables on the PV side or on the AC side, but that highly overcompensates the benefits of having a larger inverter. High PLC communications, I will also cover that later. String level monitoring, we monitor the inputs, current and voltage, and we also provide the IV curve diagnosis to detect faults on the strings. So that's it about the inverter. Then the transformer station, as I said before, we provide 3 different sizes: 3,000, 6,000, and 9,000. It's a very compact solution using a 20 feet high cube container. It includes low voltage switchgear, transformer, medium voltage switchgear, as well as auxiliaries. The idea is that everything comes prefabricated, pre-tested from the factory, so that the customer only needs to prepare the foundation and the cables, let's say, popping out of the foundation, so that you only need to drop the container with a crane, make the connections, and that's it. So it's the most plug and play solution that can be possible with a transformer station. It is also intended to be operated from the outside, so you don't need to get inside during the operation of the transformer station for easy O&M. Well, it's also based on the principle of safety and reliability, the same as the inverters, with high IP protection levels and corrosion standards. And for the European market, we also can provide the eco design or tier 2 transformers for the EU 548 directive. So now we move on to the storage solution. So we provide a PCS station that you can see here in detail. So if you look at the right-hand side compartment, you will see some vertical boxes. Those are our string PCS, which I introduced briefly at the beginning. They can go up to 250 kilowatts. So we will incorporate as many as you need, depending on your project needs. After that, all the string PCS will be combined and then connected to the low voltage side of the transformer, which you can see the center part, and later on to the medium voltage switchgear. And together with that, we provide the auxiliary services, the 80 kVA auxiliary transformer, UPS, also heat exchangers for cooling, and so on. So I would say the key part of this presentation is the digitalization part. I mean, what can we add to the digitalization of PV plants? So let's start with an intelligent DC switch. Well, actually, let me take one step back. So the inverter includes 4 of these DC switches, and they're called intelligent because you can avoid installing fuses. Because if you remember from the beginning, I thought I probably went too fast, but we have 4 strings per each MPPT. So according to IEC standards, if that's the case, we will need to install fuses or some sort of overcurrent protection devices on all the inputs, because there's a formula there. I'm not going to cover the formula now, but if you're interested, I can explain you in private. But basically, it says that when you have more than 2 strings per MPPT or independent MPPT, you need to put overcurrent protection devices like fuses. But the standard also provides you another option. It says that you can also put another device in accordance with IEC 60947. So this is what we got. And to show you how the system works, there's an example here on the right-hand side. The practical case, imagine there is a ground fault from PV1 to ground. The strings number 2, 3, and 4, which are connected to the same MPPT number 1, will backfeed their source circuit current to that fault, because it is the path of least impedance. And that could be an issue because the modules are not prepared to withstand 3 times the ISC of the module. And to prevent that, and this is where the digitalization comes into place, we have on every input current transducers that not only can measure the input current from every string, but it also can detect the reverse current, in this case from strings number 2, 3, and 4. And when that happens, the CT, the current transducers, will send a signal to the DSP, the digital signal processor, which is kind of like the brain of the inverter. And in turn, the DSP will command the DC switch to open. And remember, this is the DC switch number 1. The other switches, the number 2, 3, and 4, will remain closed, meaning that the inverter will continue to operate, but at partial load, in this case, 3/4 of the load. Also important to remember that when you need to, once you troubleshoot the problem with the ground fault, you need to go there physically to close the switch. We cannot do it remotely for safety, because imagine someone is in the SCADA room and they see that the switch has opened, and they say, okay, I'm going to close it, and then probably something happens if the problem has not been resolved. Okay, so this is the digital, the intelligent DC switch. Our latest feature that we have added to the inverter is this one. So we can measure the temperature at the input terminals, input and output terminals, DC and AC. So here you see the MC4 terminals, but behind those terminals, you cannot see them here because they are behind the plate. We include sensors called the negative temperature correction sensors, NTC sensors, and those will measure the temperature of every terminal, which is the temperature data sampling stage that you see on the left. Then the process enters into the data processing, temperature data processing, meaning that the temperature of every terminal will be compared to the neighbors. And if the delta temperature after that comparison is greater than a threshold value that by default in our case is 20 degrees, but you can change it if you want, then the protections will trigger. So the question is, which protections will trigger? Well, it depends. If the over temperature has occurred on the DC side, on the MC4 terminals, let's say, on the PV side, the associated DC switch will open. Only that switch, not the other ones. However, if the over temperature happens on the AC terminals, the whole inverter will disconnect. And this is a feature that we add by default in our inverters, so that you have it for your projects for sure. The third one is called the arc fault circuit interrupter. And as I mentioned before, the last year there was an IEC standard that you can see here at the bottom, the IEC 63027, that was approved in April, and that talks about the requirements for AFCI for utility projects, series arc faults, not parallel arc faults, because those are very unlikely to happen. And this standard covers things about what are the requirements for AFCI and the testing also requirements for passing the certification and so on. And this is something that Hopewind already has. We already conducted that testing, and our AFCI is certified according to IC 63027. And just in brief, I mean, how does it work? We cannot get a lot into the details, but indeed, the picture on the right, you see two types of bubbles. The blue bubbles are the current transducers that I explained at the beginning, that they measure the input current and the reverse current. But in a later stage, closer to the MPPTs, we include another more sophisticated, I would say, sensors that they detect the arc characteristics, because when an arc is happening, there is a high pitching noise on the signal, on the current and voltage signal, and that has to be identified by the inverter and the algorithm, and then the inverter needs to act in consequence by opening the protections. This is an optional feature in our inverters, because it depends on every country now to make it mandatory or not on the utility. But just so you guys know, we are ready for this. Smart air cooling, this is a very important feature for us, because that's how we can get to 40 degrees Celsius. And one important reason why 385 kilowatts up to 40 degrees. Because of time constraints, I'm not able to get into all the details how we get to this temperature, but I would say a couple of things. That we, on the MPPT or on the booster stage, we are not using the traditional IGBTs that we use on the inverter stage, on the inverter part. We are using silicon carbide MOSFET, which have a better behavior for higher temperatures. And it's something that we have inherited from the wind converters. I mean, we know this technology. It's difficult to control. That's why probably other inverters in the market, they still don't have it, but that's the trend, I would say. The other reason probably why we have this very good behavior against temperatures, because we have 8 fans, 8 modules, and then the inverter probably is slightly larger than probably other in the market, so we have more internal air to circulate. So that's how we get two of the points how we get to 40 degrees without getting into more details. PID recovery, anti-PID. I'm going to go quick. I'm checking the time. So I assume you guys know what PID is, the potential induced degradation. It's caused by the leakage current in the modules due to the negative potential to ground, in short. So we have solutions, both PID recovery, which comes by default, and anti-PID that has an extra cost. Anti-PID works during the day, and the PID recovery works during the night. So depending on your project needs, we will recommend you one or the other. Smart IV curve diagnosis. It's a tool that lets you trace the IV curves in real time, and well, not in real time, on demand. You need to press the button to do it, and it will compare it to the theoretical IV curve that will be correspondent to the radiation and temperature conditions on site. So based on that comparison of the IV curve shapes, the system can detect more than 10 types of fault and send reports to the O&M people, asset managers, engineers, and so on. And it will give some recommendations about what to do to troubleshoot those problems. I think this is the last one, the high-speed PLC communications. So this means that the communications can travel in the same cables as the power, as the power, let's say, the same three-phase cables. Basically, it's a technology that converts the digital signal zeros and ones to a high-frequency signal in the order of 20 megahertz and so on. And that avoids having to use communication cables like RS-485, Ethernet cables, and so on. And just to finish a few cases, 3 cases. This is our largest project in the world, 2 gigawatts in the desert of Mongolia. For this project, we're using some of those features, the digitalization features that I explained before, like PLC communications, PID recovery, and so on. And sorry, just to go back, and it's a project, as you can imagine, very high temperature, like close to 50 degrees, very sandy conditions, as you can see. So the inverter is behaving very well. And on the another, let's say, opposite conditions in very cold environment, high altitude is this one, 300 megawatt project in the Yunnan. And again, in this case, we're still using the PLC communications, the intelligent DC switch, the IV curve diagnosis, and so on. Just one last example, and I finish. It's a project closer to Europe. This is in Turkey. In Turkey, we're #1 in the market, and it was done with the smaller brother of the 385 inverter, 225. And we have this one here to show the resistance to corrosion, because as you can see, it's next to the seawater in a thermal power plant and so on. So that's it from my side. You guys have any questions? Yeah, please let me know.
I do. Thanks a lot.
Okay, Michael.
Yeah, great to see that you're actually advancing and innovating so much. Maybe when you would like to judge that all these features that you've implemented recently, so what would you consider key actually in the utility scale segment in terms of improvement? Also, when taking into consideration that the world is changing, especially here in Europe, where we have all these curtailment issues and all these and the market is changing, of course, all these services that become available. So from your view, actually, I don't know, in China, you've of course also curtailment issues, and they are probably not less than here. But what are you seeing? What needs to be done also technically? Is there still a lot to do?
There's a lot to do, but luckily, PV comes from more mature technologies, not only in renewables like wind, but also in other sectors, of course. So what has happened in the previous years is that PV was kind of like a laboratory thing. Well, not today, but it was like, oh, look at the guys doing PV, look, they're like the green guys and so on. But now it's a mature technology. All the governments are investing. We need to do that according to different worldwide regulations on the carbon emissions and so on. When we have such a commitment to integrate renewables into the grid, we need to think that when you inject power electronics into the grid, which are not rotating machines like a thermal reactors and these kind of things, they have inertia, and the inertia is good for the grid. But because there's rotating machine, when something goes down, they have rotating inertia, so they can maintain the frequency and the voltage. It's not the same with an inverter. It's based on power electronics. Something goes down in the matter of milliseconds, it's dead. So you don't have inertia. So these kind of things like synthetic or virtual inertia, grid forming, black start, and these kind of things that have been requested for other technologies, now they come to us. And we already have the solution for grid forming because we inherited that from wind. Also black star, synthetic inertia. I think that's the key to integrate more renewables into the grid. How can we support the grid rather than be an observer, right? I think there's more other topics, but that to be #1, I think.
Okay, and maybe one question also in terms of markets. Of course, we know the situation is difficult in the solar market because we have this huge overcapacities. I think you Hopewind came late actually out of, at least on the solar side, out of China to the European market. But it was interesting to hear that you're #1 in Turkey. So can you just explain a little bit how you see the market at the moment, and also what you expect in the coming month?
Yeah, it is true that at least for the European market, we are kind of like a latecomer. But it is true that in China, we are already #5 or #6, if I'm not mistaken, for the latest reports. So the reason why we came late to Europe is because the European market and probably also the US market and some other markets, they are more demanding on features. Like, for example, these kind of things like grid forming and so on. So this inverter that I presented to you guys today is the generation 2, specific for the European market, and I would also say LATAM maybe. And there are some other markets, of course, in which our solution fits very well, specifically for the 40 degrees derating, like South Africa, of course. So we have the best inverter for high temperatures, Middle East, and so on. Yeah, I think that's it.
Okay, cool. Thanks. Then there are a number of questions already in the chat, or if you could address those. And again, if anyone has more questions, please feel free. Thanks a lot for
Thank you very much, Michael. I will take care of the questions. Yeah.
Okay, great.